We'll continue talking about tries in this screencast. It's a data abstraction exercise, how to represent the trie data structure with lists and trees, and we'll start with the representation of trees in terms of lists. So this is how we represent an the empty tree, right? The tree with no branches. So let's suppose that we've inserted one branch, A. So we have the root, and then we'll have one branch that begins with A, right? Those like character A's. Okay, let's see if we have inserted another branch that starts with B. So we have the root, then the A branch, and the B branch, right? So the root has two branches, A and B. Okay, so let's redraw this tree quickly here. A, B, and C. And we can, right, now we have the root, then we have the A branch, the B branch, and the C branch. Okay. So let's say we have inserted D under A, then the tree representation in terms of lists will be A, and then under A we have the D branch, and then B and C. Okay. Now the trie also has buckets. That's where we store values, right? And in our case, we'll represent buckets as two tuples. The first will be the string, that's the actual key, and the second will be a one element list. So there's a subtlety here in that although the two tuple is immutable, the one element list is mutable so that we can actually change the value of the key. And the key is the string on the path leading to this bucket. So for example, we start with the empty tree, and then we, let's say, insert 2, right, the key 2, and then here's the bucket. So the string 2 and the value, let's say, will be 7. Okay, so now after that insertion, we will have the root, and then T, and the T has sub-branch that begins with O, and after O we have this bucket 2 and 7. Well, actually 7 should be inside the list, but I'm running out of space here, so let's match the parentheses. Okay, so matched O, matched T, and matched the leftmost parentheses. Okay, so this is what our trie is so far. So T, O, and then let's insert T. Alright, so we are inserting the value, the key T, and the value of 3. And okay, so that's our bucket, right? Now, after the insertion of this bucket, the trie looks like, so we have T, and we have, under T, we have O, and then there's a bucket. Right, okay, so it's actually inside a list. 7 inside, let's correct this to put that 7 inside the list. Okay, So that's the O branch, and then also under T there's the E branch that has the A sub branch, and then there's a bucket. That's the second element in the list that starts with A. Okay, so matching A, matching E, matching T, and then we have to match the leftmost square bracket. Okay, that's the entire list. Okay, let's take a quick look at the Python implementation. This source code is available in the link underneath this screencast, in the description of this screencast. So there's some helper functions. So this is the Boolean predicate that tests if x is a bucket. It's an instance of a tuple. Length is 2, and the first is a string. And the first element of the tuple is a string, and the second element is a list, and the length of the list is 1. And then there's the getter, two getters, get bucket key and get bucket value. And this try branch well, returns true if it's a list. So this is the insert key function. If the try already has a key or the value is the same as is currently stored, then we don't do anything. Otherwise, we set the try to the root, find the child branch that starts with the current character in the key. If the branch is not found, we just create a new branch and append it at the end of the try, the current branch of the try, or rather. Set the try to the new branch, and afterwards we just append the bucket to the try. This is a function that returns the child branches of the current branch, which is everything but the first element in the list. And that's a function that finds the child branch that begins with a specific character. So we just test if the first element of the list is the same as the character, then we return that branch. Otherwise, we return none. It's the function that checks if the key is in the try, retrieves the branch. That's the retrieve branch function is defined below. We can move it up here inside of the hash key part of this module. So retrieve the branch and so just start drilling down the try finding branches and setting the tr variable to the value of the current branch and ultimately returning tr. So how do we retrieve the branch? If first of all, retrieve value from the try. First of all, if the key is not in the try, we return none. Otherwise, we retrieve the branch and get the bucket from the branch, the bucket value. And this is a function that returns all of the keys that start with a given prefix. We find the branches, then on the prefix, and then collect all of the bucket keys and add them to the key list. And then we return the list of the keys. There's a couple of tests at the end of the file. So the first constructs the tree from the Wikipedia article. Then there's a couple of other functions that construct. One of them constructs a tree from Rumi's poem, The Tent. So let's go and construct the Wikipedia article. Try run test 1. Okay, so this is the try, and we can check if it has the key 2, and it is true. Let's check if it has the key coffee, which should return false because it doesn't, and it does return false. And let's check start with prefix. Okay, start with prefix 2, tr.